Well, thank you very much, Charles, for that kind introduction. I hope you don't mind if I stand out here and wander around. It kind of will help keep the energy level up, I hope. And I'm just delighted to have this opportunity to speak with you. Today, I'm going to share with you a summary of the work done by our team of engineers, scientists, and economists looking out to the future for energy. And let me emphasize right up front that we do this work mainly for ourselves. This is the piece of work we use to guide all of our business plans and strategies and to underpin our billion-dollar investment decisions that we make throughout the year. And one of the points I want to make before I get started is that we very much focus on future consumers. This is really fundamental to our approach. And really, this is just kind of business 101. The only way as a business for us to be successful is to meet the needs of future consumers, because we have billions of people around the world who rely on getting reliable and affordable energy, and at a scale that you're going to see is quite immense. So it's a huge challenge for us as a business. So with that, let's go ahead and get started. I'm going to go through a lot of materials. I hope I don't go too fast, but I find no one ever asks me to go slower. And there will be plenty of time at the end for questions. So first, I just want to emphasize that we do take a bottom-up approach to the outlook. So we look at each of over 100 countries, country by country and sector by sector, and within each sector, we consider all the different fuels that are available to consumers. We also, importantly, have to look at trade flows across borders because, of course, where you find the energy and where you need the energy can often be different places. And I always say probably the most important forecasting challenge is future policies. In the world of energy, government policies have a huge impact on the energy outlook, and it's probably one of the hardest parts of developing a forecast. Now, as we develop the outlook, we talk to lots of people, not only our own engineers and scientists, we talk with university researchers, we talk with other policymakers around the world who are always keen to hear our view, kind of what makes sense for future societies and consumers, and so we try to integrate all of that into the outlook. Now, before we get into the numbers themselves, if you'll bear with me, I know this is a very sophisticated group here, but I want to talk a little bit about energy units and how energy at the kind of person or individual level builds up into these huge numbers on a global scale. We talk about energy measures. You can pick any unit you want to measure energy, just like with distance, you can use kilometers or miles. You have lots of choices with energy. And I'm going to suggest, for the purpose of discussion, that one of the first uses of energy, of course, was to build fires. So you could say that the most basic unit of energy is the amount of energy in one log of wood. Now, in modern terms, that's equal to about 24,000 BTUs, or British thermal units. You can convert that into a more common reference of gallons of gasoline. Sometimes we talk about energy equivalents in terms of barrels. People see electricity in kilowatt hours on their electric bills. So you have 1 gallon of gasoline is equal to 36 kilowatt hours. That's equal to 13,000 AAA batteries, just to give you another reference. And if you're a millennial, you might relate more to smartphone batteries, 4,000 smartphone batteries. But now what I want to do is to talk about a world demand for energy and how big a number that is. But one point I want to emphasize is that when you talk about energy, you always have to start with people, because it's all about supporting the standards of living for people. So I just want to take one slide to talk about the energy that one person uses in one day. And we're going to use our log units here. First, for household use, this is for heating, air conditioning, electricity. It would be equivalent to the 7 log units. Then you look at personal transportation, fuel for your car, another 6. Then industrial use, we sometimes forget that you need to use energy to make all the things that we use. Then you have commercial transportation, moving all the materials around for consumers. And then lastly, you have commercial buildings, schools, hospitals, and stores. So when you add that all up, in one day, each person needs the equivalent of 34 of our energy units. And again, just to translate that into more relatable form for you, it's 7 gallons of gasoline equivalent. Now remember, that's one person and one day. So now to take this, we want to move to a global scale, and we're going to look at how much energy the whole world needs today. So we start with this one person, and the first point I want to make, if you move to the right, is that most people in the world do not use as much energy as we do in the United States. And you can see the difference is quite striking. Instead of 7 gallons of gasoline equivalent on average, it's only 1.7 on a global basis. And this is because of standards of living are not as high in the rest of the world. And we'll talk about that also. So now it's just a matter of simple math. We have to multiply. There's today 7 billion people on the planet. And so when you do the math, it comes up to the equivalent of 12 billion gallons of gasoline equivalent every day. This is how much energy we need to kind of make the world run. And for those of us who work in the energy industry, this is a challenge of enormous scale, that every day before we go to bed every night, we've got to make our 12 billion gallons of gasoline equivalent. We need to provide that reliably and safely for consumers. So the energy business is a very large-scale business. All right, now the next, as we talk about the energy outlook numbers, we're going to use millions of barrels a day of oil equivalent and mainly quads. Quads is quadrillion BTUs. I know you know quadrillion is a million billion, right? Okay. So now I'm going to start with this one slide which really summarizes the overall energy outlook, and then we'll kind of get into the details for the various sectors. Again, we always start with population. Energy is about supporting people. We show the world population growing from 7 to 9 billion people over this period. And this is pretty consistent with what most forecasters expect. And actually, most people expect the world population to kind of level off after that. Importantly, the next thing we look at is economic activity measured by GDP. And we show the world economy more than doubling over this period. So the logical question is, with the world growing by 2 billion people, the world economy more than doubling, how much more energy does the world need? Looking out to 2040. And here you see in our energy outlook, we show that the world would need 35% more energy. Now right away you can see quite a striking trend here. Look how much slower the growth in energy is compared to the growth in the economy. And this is because of energy efficiency. It's a very, very powerful idea that we continue to use energy more efficiently in all sectors. In fact, just to emphasize this point, is this line shows how much more energy the world would need if we did not assume efficiencies in our outlook. And this is why we sometimes say the greatest source of energy for the future is just using energy more efficiently. Now lastly, this is kind of the top-level outlook. I want to just give you some slices here for each one of these charts by talking about different countries and regions around the world. If you'll bear with me, I'm going to use some of these same labels throughout. On the bottom, if you look on the left panel, OECD, these are the developed countries like Europe, the US, and Japan. You can see that, of course, most people are not in the developed world, they're in the developing world. And we highlight China, India, what we call key growth countries, which are some of the countries that have the highest economic growth and energy growth. And lastly, the rest of the world. Again, most of the people are in the developing countries. You look at economic growth, you basically see expansion of everyone's economies, although the pace of growth is clearly higher in these developing countries. Now, in energy on the far right, again, you see two striking trends. First of all, in blue, in the developed countries like the US and Japan and Europe, the demand for energy is absolutely flat. It's actually declining a bit. So this is an incredible accomplishment that our economies will continue to expand, but we won't need more energy. When you look in the developing countries, you see that's where all the growth in energy demand is, in these developing economies where we have the rate of expansion of economic activity is so much faster. So that's the top line look at the outlook, and now we'll talk about some of the sectors. I guess I also want to talk a little bit here about the whole challenge of living standards. Here we're looking at GDP per capita, again for these same groups of countries. And the top of the bar is GDP per capita for the year 2040. And the dotted line is where they are today, or in our reference year of 2010. So the difference is the increase or growth in living standards over this period. And a couple of observations. First of all, of course, the standards of living and GDP per capita is the highest in the developed economies, but everyone is improving. But even by the year 2040, there's still a huge potential for improvement. Now, at this point, I always like to say, it's more than just GDP statistics. Again, we're talking about people when we talk about standards of living in GDP. We have today 2.6 billion people on the planet that do not have access to modern cooking fuels. And of course, everybody would like to have access to cleaner fuels and to be able to enjoy having access to modern energy. Same thing when you look at electricity. Today, 1.3 billion people do not have any access to electricity whatsoever. And this is actually the biggest theme in our energy outlook, is the world needs more energy to support the improvement in living standards. Now, as we talk about the energy outlook, we have both a supply side and a demand side. And I'm going to start by talking about energy demand. And we break it down into these 4 categories or buckets, if you will: electricity, industrial, transportation, and residential commercial. And we're just showing here the bar to the far right in each case is the demand growth in the year 2040. And just for the sake of time, I'm only going to make one observation here, is please notice that electricity is not only the largest sector, but it also is the one that has the largest growth. But let's start with transportation. Everybody likes to hear about transportation as a sector. And this chart on the left here shows you, again, going out to the year 2040, we have a huge growth in the demand for transportation fuels. But again, a couple of quite important trends. If I can direct your attention to the bottom of the chart first, light duty, this is mainly cars, just think personal cars. Again, we have this striking trend. The demand is absolutely flat. Now, as it turns out, there's 2 big things which equally offset each other. We show the number of cars doubling over this period, but we show the efficiency of those cars also doubling, so they tend to offset each other. And I'll talk on the next slide a bit more about automobiles. So all the growth in this sector is for what we call heavy duty, marine and aviation, which is really moving around materials as part of economic activity. I say, this is not complicated. You make more stuff, you got to move more stuff around. It tracks and correlates very closely with economic activity. Now, on the right, we show in the world how the demand for transportation fuels changes. Again, you see the highest demand level is in the developed world, but the demand is actually going down in the developed world. All the growth is in places like Asia. Now, the next chart, we talk about light-duty vehicles or cars. Everybody kind of wants to know, what are we assuming people will be driving in the year 2040? And this chart tries to answer this question as we look at the composition of the vehicle fleet out by the year 2040. And I just want to direct your attention to the light blue second from the top there. And this is hybrid vehicles. You can see we show hybrid vehicles becoming dominant in the future. It takes a long time to actually affect the vehicle mix because you have cars in the population for many years. And just to be clear, when we talk about a hybrid vehicle, we mean a car like the current Toyota Prius. Many of you are probably familiar with that. But basically, it has on board both a conventional internal combustion engine and an electric motor and a small battery. And I always say this is kind of the best of both. You have the convenience of conventional fuels, but you also have the efficiency of an electric drivetrain on board. And so you can get very high mileage. And so we see this as becoming the dominant vehicle in the future. And by the way, this is driven mostly by government regulations. In almost all countries now, governments are pushing the car companies to make ever more efficient vehicles. I will point out, if you look at the top, we do show significant growth in electric vehicles, but they remain relatively a small share of the total. And this is because still electric vehicles are challenged by the costs and the range and the recharging time. And so in our view, unless there's a breakthrough in battery technology, it will take time for them to become more popular. All right, the next sector I want to talk about is industrial, which is actually a very large sector. Again, it's invisible to most consumers, so you don't really think so much about this, but we show about 40% growth in industrial fuels. And just briefly, for chemicals, it turns out in developing countries, as people earn more money, they actually use a lot more plastic products, and so the demand for chemicals grows faster than GDP. The real core of this sector is heavy duty. This is making all the steel and the cement. You think about these big cities in China, it's a huge amount of money being spent to build these cities, and it takes a huge amount of energy to make all the steel and the cement to support that growth. Then you have the energy industry itself, and lastly, other miscellaneous sectors like agriculture. So that's a big sector in the energy outlook. The last sector that I'm going to talk about is electricity generation. And remember, this is the largest sector, and it's the sector that has the greatest growth. Now here, if you'll bear with me, it may seem a little complicated, but across on the scale on the left here, we're showing electricity demand by person or per person, electricity per capita. Okay, so the higher living standards you have, the more electricity you use per person. Along the bottom scale is population. So if you multiply these two, the size of the rectangle gives you the size of the electricity demand in that region or country. Now this is in the base year of 2010. Now let's watch what happens when we fast forward to the year 2040. You can see that everyone's number goes up because of improvements in living standards. They also move out to the right as populations expand. But basically, what this shows you is because of improvements in standards of living, the need for electricity almost doubles over this period. So this is a huge impact on the energy outlook, because the question is, what kind of energy and fuels are we going to use to make all of this electricity? You know, people don't think too much when they plug in their iPhone charger. What fuel is really being used to make that electricity? And here we're trying to show you this for Asia Pacific. I wanted to put a few charts in here in view of being here at the Asia Society to talk about the demands in Asia and the outlook for Asia. And here we show for the total outlook for Asia Pacific broken down by major regions and country. Obviously, China is kind of the biggest factor here. China today is not only about half of the energy demand in Asia Pacific, but the growth is more than 50% from China. You also see India continues to grow quite significantly. On the right side, we show you the mix of fuels expected to meet the demand in Asia Pacific. And just a couple of points here. First of all, you know, everyone knows coal is under a lot of pressure, mainly because of environmental considerations. And so you do see a fairly dramatic trend with coal peaking in Asia around 2025 and then slowly beginning to decline. But it does not go away. Because of its importance to the energy mix, you're still going to see a lot of coal being used in Asia Pacific. You see gas, natural gas, is actually growing more than any other fuel, not only in Asia Pacific, but just about everywhere in the world. And this is because natural gas is particularly attractive for making electricity. Remember I told you the world needs almost twice as much electricity, and natural gas is particularly attractive for making electricity. It's about 50 to 60% cleaner than coal in terms of CO2 emissions. It's, of course, everyone knows now we have huge resources of natural gas available, so it's affordable. And we have technology, these very efficient combined cycle generators to make electricity from natural gas. So it's one of the largest growing fuels in the world. But notice we also show expansion in nuclear. The Chinese are building nuclear plants at really maximum pace right now. So we do show a significant growth in nuclear. And nuclear is kind of an interesting space because it really depends on what country you're talking about. I use as an example, just look at France and Germany, two countries right next to each other. I don't think I could say similar cultures. I don't think they'd like that. But the fact is they come to two completely different conclusions about nuclear. You may know France relies extensively on nuclear power, where the Germans have said they're completely walking away from nuclear power. So it's kind of got a big social overlay on nuclear. All right, also in Asia Pacific, I want to talk a little bit about the penetration of cars in China. Here we're showing, again, on the bottom, GDP per capita, which again tracks living standards. And on the left scale, it's number of cars per 1,000 people. So you can see that China is moving up over the period of the outlook to about 300 cars per 1,000 people. Now, one of the things we do when we look at our outlooks is we try to compare with other countries. And here I have an overlay of many other countries and how they've tracked over time. And you can see, for instance, that the China line is very closely tracking the experience of South Korea. So we think that's a pretty good model of probably where this is going to go. But one thing you can probably guess looking at this is there's a huge potential for more cars in China. And this is a big part of anybody's outlook, trying to estimate how many cars you're going to see in a place like China, which, of course, the car companies are very interested in also. 800. The U.S. would be 800, which is, of course, about the top of any country on that. In fact, we didn't put it because it's kind of off the chart. We use a lot of energy for lots of reasons. Now, this just puts another overlay on how things have changed in China and how they've really started to pick up in buying cars. On the bottom line shows, if you look at the scale on the bottom, it's kind of income groups. And you can see basically only 10 years ago or so, in 2002, only the top income, top 10 or 20% could afford to buy cars. And you look today, you can see that people are buying cars across all income levels. So, of course, again, there's huge potential for the deeper penetration of cars in China. Also, we talk about electricity and standards of living. Here, again, just looking at China, we're showing the penetration of appliances going back to 1990. You can see, for instance, that look at something like refrigerators. Back at the early part of this time, more than half the people did not have refrigerators. And now, of course, that penetration is going up for all of these things. And of course, I always say this is the easiest part of the energy outlook to explain, which is people everywhere around the world want all the same things we do. They'd like to have clean cooking fuels, a TV, refrigerator, cell phones, and someday maybe buy a car. And of course, it's a good news story, but it means we also need more energy to support these things. So, for the sake of time, I'm going to skip that. The last chart on Asia Pacific here is looking at China electricity demand. The demand for electricity in China, because of these trends, more than doubles over this period. And lastly, looking at the mix of fuels to make electricity in China. And again, you see this same trend where you see coal peaking in about 2025 and then starting to decrease quite dramatically as it's replaced by natural gas. You see nuclear now starts to be quite a bit more significant, and also significant expansion in the renewables like wind and solar. Now, this last chart, this wraps up the demand side of the energy outlook. And here what we look at is that on a global basis, again, all the fuels that the world needs in 2040, and we kind of put them in order in terms of the size contribution to the world energy demand. The top of the bar is the demand for that fuel in the year 2040. The dotted line is where we are in the base year of 2010, so the difference is the growth. And the percent number at the top is the average annual growth rate. And just a few observations. First of all, oil remains number one, mainly because of its uniquely attractive properties for transportation. Obviously, liquid fuels are so, convenient for consumers. You know, with transportation, you got to carry your fuel with you. People don't think about this, but with just what is only about 100 pounds of fuel in your car, you can take a 4,000-pound car at 70 miles an hour, you can go 400 miles, you can have the radio on, the air conditioner on, and so it's a very, very convenient proposition for consumers. Natural gas is the largest growing fuel compared to any other fuel here. And this is, again, because it's particularly attractive for making electric power. So we show natural gas growing more than any fuel. Coal remains kind of flat, and this is because of environmental pressures. But again, it does not go away. And we'll talk about the environment on my next slide. And then lastly, I just want to point out, second from the right, we show the renewables of solar, wind, and biofuels. And I just want to point out, please notice that the number at the top, the growth rate of 5.8%, is the highest number on this chart. So when you hear stories that renewables are growing faster than anything else, it's true. But they're starting from a very low base number. So by the year 2040, they still make only a kind of modest contribution to the overall picture. Okay, so that wraps up the demand side. And before we go to the supply side, I have just one chart to talk about the environment, or CO2 emissions. And here we forecast CO2 emissions looking out to the year 2040. And basically, we show them peaking in about the year 2030, and then they slowly begin to decline. Now, again, a striking trend here. If you look at the developed world in places like the US, we show significant improvements beginning immediately. We're showing CO2 emissions going down, and a lot of this is driven by regulatory policies, but also driven because we're using more natural gas. So all of the growth, all of it, is in the developing countries. Now, this is very important because when you talk about these international negotiations to try to reduce CO2 emissions, it's critical that those negotiations are among all countries. It really is an international challenge. Of course, it's enormously difficult to negotiate these treaties given the impact on the economies of all these countries, but still, from a practical and engineering standpoint, you really have to work this on a global basis. Now, whenever I show this chart, I always worry that people will say, well, we know what the problem is. It's all these developing countries, right? So I insist on always showing the right side. This is the emissions per person, okay? Now, right away, you can see here that one of the reasons that we can hold emissions flat is because we already have all of our stuff, right? We have our high living standards, our high use of energy, and so it's easier for us to improve upon that. In the developing countries, they have much lower living standards, and so they naturally use less energy, but they're going to have to increase their emissions as they try to improve their standards of living. So again, I think this is an important overlay. And this point is not lost among the developing countries who say, you know, if you really are so concerned about the environment, you need to help us. And that's really the theme. So it's a big challenge. Okay. Now we're going to lastly wrap up with the supply side of the outlook, and I'm going to start with the outlook for oil or liquid supplies. And again, looking out to the year 2040, and I've kind of broken this down by technologies. The bottom green here is conventional crude oil supplies, which you can see is actually kind of flat. So all of the growth required to provide supplies for the world are coming from these what we call new technology areas, deep water drilling. You know, it's pretty incredible what we can do in the industry now that was unthinkable 20 years ago. Today, our exploration people and drilling people can go out in the Gulf of Mexico in water that's 2 miles deep, go to the ocean floor, drill through the ocean floor, go down 2 miles more, take a right turn, go 3 miles, and identify a pocket of oil. It's just incredible. This was all unthinkable 20 years ago. So we can do this in lots of places around the world, and it's a significant area of growth in terms of oil supplies. Oil sands in places like Canada, there's lots of technologies that have been developed to economically extract oil sands. Tight oil, this is the shale oil that we all read about, which we know has kind of revolutionized the supply side. In fact, you know, we now talk about the new era of energy abundance. You know, we all grew up with energy scarcity. Well, we were in this new age now of energy abundance because of technologies. And we show natural gas liquids. As we make all this additional natural gas, you're going to have a lot of liquids that comes with that as part of the production. And I do show biofuels at the top in yellow. And again, you can see it remains rather limited, mainly because they still are very expensive. Most of the biofuels that we have in here are because of government mandates and regulations. They're really not quite economic. Everybody's working on that, including ExxonMobil. We're doing a lot of research to try to develop biofuels that can be affordable for consumers. So I would say that's certainly a space to watch. If you look at the green space for a minute there, I also like to emphasize that you have to keep investing in conventional development in order to maintain that production. It doesn't happen naturally. Most of these oil fields actually decline over time, so we always like to remind people, just because it's flat doesn't mean we don't have to still keep investing in that space. And lastly, you know, people often ask, well, how much oil is left in the world? And this chart actually shows the estimates of total resources of oil in the world, but by date, going back to 1981. And it's kind of an interesting outlook because you'd think this number should keep going down as we keep using more oil. But in fact, the number keeps going up, and it's because of new technologies. As we find new ways to produce and discover oil, then we can recognize that we have more oil to produce. And so this is another positive story of human innovation. Because of the advancement of technologies, the estimates of oil reserves continues to grow. In fact, if you do the math on this, it would say from today, we have 100 years of supply in the future, just based on this number. Now, I also want to talk a little bit about energy trade. I mentioned earlier, one of the key parts of the energy world is where you find energy is not always in the same place that you need it. So energy trade is critically important. And trade is really the lifeblood of the energy system. And for the sake of time, I'm just going to fast forward to this one slide here. What we try to do is for all these regions to show the demand and supply picture and who are the exporters and who are the importers. If I could direct your attention first to North America, the dotted line is the level of demand required in that region. And the bars are showing the supply. So if the supply is higher than the dotted lines, it means they're an exporter. Like obviously, if you look at the Middle East, you could see that they're a huge exporter to the world because they produce so much more energy than they need. So the trends here, it's kind of interesting for North America. Of course, the big new thing in North America is that we're now going to become an energy exporter. And this is showing you oil, but the same is true for natural gas. And you can see the other big exporters are actually Russia, Caspian, and the Middle East. The two big areas that will remain heavily reliant on imports are Europe and Asia-Pacific. Asia-Pacific in particular, as if it's huge demand growth, they really don't have enough of their own energy to supply that, so they're going to continue to rely on imports. Now, that always sounds like a negative thing, and it really doesn't have to be. As long as there's adequate supplies, and these days there's little question that there's adequate supplies, that as long as there's adequate supplies at reasonable cost, those economies can continue to thrive. I always use as an example Japan. Look at Japan, doesn't really have any of its own energy, but for many, many years has been able to have a thriving economy using imported energy. So I know that was a really fast whirlwind of the energy outlook, but I want to just conclude here looking again at the demand for energy into the future with 35% growth in energy. And again, you can see by regions here that all of that growth is in Asia-Pacific, kind of fitting for this group as we talk about the Asian society, that it's energy that really is going to underpin the expansion and the improvement economies in the world of Asia-Pacific. So when I'm done, my public affairs people always tell me that when you're done, you're really going to be lucky if people even remember one thing you said. It's always kind of discouraging, frankly, to think that, but even though I admit it's probably two. So I'm going to challenge you and give you 3 things to remember. These are the 3 things that I think come out of our energy outlook. Number 1, what's driving the need for energy in the world is the improvement in living standards around the world. And this is a good news story. That's something that everyone should feel good about. The second thing is the world needs a lot of energy, and we're going to need 35% more in the future. So it is a big and important challenge. And the third thing, and I think most importantly, is another good news story, is that the biggest factor in all of this is technology and the improvement in technology over time that has helped us with efficiency and identifying new supplies, how to find new oil, and how to use energy more efficiently. And this is fundamentally a story of human innovation and the power of human innovation. And if you look back in time, I would say that we have every reason to be very optimistic for our future because it's going to be better in so many ways that we don't even know now because of human innovation. So that wraps up my formal remarks, and I'm happy to take questions. Yes, back here.
Would be quite robust over this period of time. I can't remember if it's 2014 or 2010. But the expansion of coal use in power generation would be high. But in one of your final charts, you said coal production would only increase less than a percent or 2.
Right.
What's going on there?
Yeah, the question is what's really going on with coal, because you said it was increasing, but then the chart showed it flat. And what happens there is coal is continuing to increase over the next 10 to 15 years, but then it declines quite dramatically. So it ends up back where it started. So when you look at 2010 versus 2040, it kind of ends up back where it started. So it kind of goes through a peak, and then I'm doing it backwards, and then goes back down. Does that make sense? And again, it doesn't go away. I mean, coal is a very affordable form of energy. And in countries that are economically challenged will continue to use coal. But there are significant environmental pressures reducing coal, even in places like China. In the far back there?
Thank you for your wonderful presentation. And as a follow-up to this gentleman's question, would you please elaborate on ExxonMobil's strategic trajectory with respect to LNG and the rise of gas as opposed to coal with respect to power generation?
Yeah, thank you very much. And the question is ExxonMobil's strategy with regard to natural gas, although I should caution you all that I don't like to talk too much about ExxonMobil's strategy, rather focus more on the global outlook, but I will answer that question. And that the outlook clearly points to natural gas as being the area of greatest growth in the energy business. So, of course, we are all over that as a corporation, as are many others in the energy business. And specifically, he asked about LNG. For those of you who may not know, that's liquefied natural gas. And this is a way where you can take natural gas, even in the U.S., for example, you cool it down to a very, very cold temperature, turn it into a liquid so that you can load it onto ships and move it anywhere in the world. We show that business increasing by a factor of 3 from today into the future. So it's a huge area of growth. And so ExxonMobil, again, like a lot of other energy companies, have very aggressive plans to pursue that growth. It's actually a very competitive market because we're not the only ones who would like to support those customers in the future with LNG growth. In fact, right now, one of the controversies for LNG is whether we're going to be allowed to export LNG in the U.S. Right now, the regulations require each one of these projects to be approved by the government, project by project. And we think this is an unnecessary constraint on trade. You know, it's almost hard to imagine that you have to go to Washington and ask for permission to export. Most countries agree or understand that exports are positive for the country, but energy is always a different world. And so there's a lot of people talking now about liberalizing energy exports, both for LNG or for oil, because the fact is this is an opportunity for the U.S. that if we don't take this, other suppliers in other countries will be happy to take that market. And so we think this is a unique opportunity for the U.S. and that we ought to seize now while we have that opportunity. And now the U.S. has huge resources of natural gas. So it's one of the great things about trade and exports and imports, for that matter, is it's the ultimate win-win. Both the importing and the exporting country end up with better economics. That's why trade is positive. You know, Adam Smith explained that 200 years ago. Adam Smith also explained that when you want to export something, there's going to be local people who are going to complain, right? And so he also explained it was always going to be very political, and he was right. I'm sorry, yes, sir.
So you made a very valid point. Thank you for the presentation. I think in Asia and Europe, which will be continuing to import, one issue that you mentioned was adequate supplies at reasonable price. Now, if you look at the LNG market, it's a place which, unlike oil, is not fungible. Here you pay probably $3.50, which is the local price, Henry Hub. Europe, they pay $12. Most consumers in the Asia Pacific pay anywhere between $16 to $18 per. Do you see pressure on the suppliers to move to a more realistic pricing range so that most consumers of energy can actually benefit from free market principles rather than opportunistic pricing?
Yeah, thank you very much for that question. And just to repeat the question, in the world of LNG, he's making the point that traditionally there was a very fixed kind of pricing model. Because traditionally the way you would develop an LNG project is when you found gas in a place like Australia, for example, the oil company would say, let's go talk to the consumer, maybe a company in India, and say, look, we're not going to build this LNG project until you agree to buy our product for 30 years at a fixed formula pricing. Once we have that contract, then we'll go and make the billion-dollar investment, and everybody wins, right? So you get the gas you want at the price you agreed, and we get the return that we wanted in building the project. So it was a kind of a constrained deal, and it's kind of a locked-up deal. It doesn't feel much like a day-to-day free market like you see in other markets. And I would say that world is changing quickly. I think, for instance, right here in the U.S., we now have LNG suppliers in the Gulf Coast who are building terminals to take gas prices at Henry Hub floating prices and under a formula to process that gas or selling it into Asia. So I say that market is evolving. But when I step back and think about all this, is that whatever you do and however that market evolves, it always has to be a win-win for both the consumer and the producer, countries and companies. And so even as that world evolves and liberalizes, and I think it's clearly going in that direction, still you need to have both reasonable prices for consumers and you need to have reasonable returns. Otherwise, it doesn't work. So I would say watch that space. It's evolving quite quickly. And I think it's going to be a good news story for consumers. Certainly, that's where we are today as we look at prices. And you can buy LNG on the spot market now, too. And in fact, it's quite attractive today. Yes, Eddie.
You had great growth projections for tight gas and tight oil, but you didn't say where it was going to come from. What is the outlook for tight gas and tight oil in North America?
Well, in this time frame, and of course it's changing very quickly as the rig counts are dropping daily. And so it's kind of, how do you catch a falling knife? I mean, that trend is down quite steeply. But I would say we'll continue to see a mix of supplies into the future. In the near term, you've seen the rig counts drop quite dramatically in the U.S. In fact, I think from a year ago, they're down just over 50%. So now it's going to take time because, just because the rig count drops doesn't mean the production drops right away. But you're going to clearly see a market response to that. One of the things we know in our business is that it very much is a free market and people are responsive. When prices go down to where they are today, people react. And so you're going to see the supplies realign. But if we look into the future, we still see, look at OPEC versus non-OPEC. It's still kind of a 50-50 mix of that. So, the world needs a lot of oil. So you're still going to see supplies from all of these places. But basically, it's the highest cost tiers that are going to start to fall off or maybe get deferred into the future. Yes, in the back.
I understand that China has even greater shale resources than the United States. Do you believe that they're going to be able to tap into those resources? And if so, what will be the global dynamic shift that will see from that?
So the question is, China has huge unconventional resources and gas also. And so how do we see that playing into the energy outlook? And by the way, that's true not only for China, but for lots of other countries, places like Argentina and even Europe and Germany has unconventional supplies. But one of the things we've learned, and others have learned in this space, is just because you have the oil and gas doesn't mean it's going to be the most economic supply. And part of it is you have to get out there and you have to try. You have to do the drilling. You have to see if it's economic. And every field can be quite different. And so there's a lot of activity in China right now. Some of that's worked well, some of it not so well. And our outlook, we do show that growing significantly, not only from China, but from other countries. And frankly, part of that is just kind of a statistical guess on our part, because we don't know where it's going to work and not work. So I would say there's a potential for that to become significant. Of course, it's going to be greatly helpful to China as they develop their own supplies. But my guess is they're still going to need a lot of imports, too. And of course, that's good for them if it's cheaper than their own production anyway. But that's in general a space to watch, how that's going to grow in other parts of the world. Yes, sir.
You talked about improvements in technology as being key to demand growth in your forecast. How much, give us a sense of how much of an improvement in technology or efficiency you would do in your forecast? I mean, efficiency improved, maybe in terms of, say, miles per gallon, in terms of fuel efficiency for cars.
Well, and the question is, what are our assumptions for efficiency improvement in the outlook? And the first thing I think about is there's a lot of assumptions, because we do this sector by sector. And so it gets down to, cars versus appliances and refrigerators versus washing machines, electric jet engines. So we look at each one of these sectors one by one. So they're all quite different. I would say autos are probably one of the most aggressive spaces. Just to give you an example, we assume, for instance, the average mileage will go up to almost 50 miles per gallon worldwide. And that's compared to about 25 today. So that's a pretty aggressive look. Now, interestingly, as I mentioned, that's driven mostly by government regulations. So, in fact, an interesting dynamic that we have to kind of estimate is we know what governments want to do and we know what consumers want. What do consumers want? They want big SUVs that go fast, right? So we've kind of got this collision course and how that's really going to work out. And one of the hardest jobs we have is we know what governments say they're going to do, then we have to say, okay, what do we think is really going to happen? Like you can ask me, do I really think what the U.S. is saying in terms of CO2 reductions is achievable? I would say no, not with the current trajectory we're on. And so we have to put in our outlook, what do we think is really going to happen? And that's not to say it's not a good intention or it's maybe not an inspiration to do better, but we're always dealing in realities. What do we think is really going to happen? Yeah. By the way, the average, I think, over the period is about 1.8% per year over this whole period, when you wrap it all up to be more quantitative. Yes, sir, Bill.
Once upon a time, there was a gas station on every corner. Those have all been replaced by banks, I think.
Yeah, they have all the money.
Half the gas stations are now Kroger, H-E-B. Tell us what's happened on from the major's point of view, operating and retail. Is that something now that other people can handle and the majors just refine and distribute? But it's been an interesting, you can't find a gas station sometimes.
No, it's a great point. The question is, what happened to the old-fashioned neighborhood gas station? Now we have these mega stations and 7-Elevens, and it's true. And I would say it's another good example of just market evolution. And again, this is a good news story for consumers. Over time, consumers have voted with their feet and with their 4 tires, I suppose, and saying, look, we want to go to a place where we're not just getting gas, but we can pick up a drink or a loaf of bread or whatever. And so it's moved to that model, which also means that to be good at that, you have to be good at both pumping gas and running a convenience store. And for some companies like ExxonMobil, we've decided we think other people are better at that than us. And so we have a model. I mean, we still obviously have our logos out front, and we're very happy to supply the fuel, but we let others kind of operate that. And it's kind of a mix in terms of the different oil companies and the approach they take to that. But to me, it's another just consumer good news story as those markets have evolved. But there's probably far more sales and revenue from the convenience store than they are from the gasoline store. And those corner lots are expensive. You got to generate a lot of revenue to support that, and that's part of what's driven that.
On the supply side, we've talked about a lot of things, but you didn't really talk much about the geopolitical issues that go into determining what supply you expect to have come out of various places, such as Venezuela, Libya, Saudi Arabia, Iran.
Right.
How do you factor that in, and what do you see happening in places like Iran and Venezuela?
Yeah, that's a great question. And the question is how we factor in geopolitical risk in our outlook for supplies, and particularly in places that are obviously challenged, places like Venezuela today. Now, I'll answer in a technical way first and then kind of get into a broader answer. But technically, when we develop the outlook, for every single year in the outlook, we have to identify where every barrel is coming from. So I have a guy on my staff, that's all he does. For any year, he'll tell you exactly where all the supplies are coming from, which projects in Saudi Arabia are going to go forward, which ones won't. And we try to estimate all the sources. Now, when we do that, let's say we need 100 units of oil. We always make sure there's capacity in that year for 105 barrels of oil. Because we always know there's going to be geopolitical disruptions, and so the world has to have an oversupply of capacity in order to provide reliable supplies to the world. Because we know, realistically looking back in time, that there's always going to be disruptions, and some of them are difficult to predict. So take a country like Venezuela and say, well, what is our outlook for production today versus what it was 10 years ago? And the answer is it's lower because of the because of the political problems that they've had in Venezuela. So every year we kind of do a relook at that in terms of where we think that's going to go. And so again, it's another area where we have to kind of handicap production. And it's kind of in fact, if you look at what we call disruption volumes today, it's all the usual places, Venezuela, Nigeria, Libya, or obviously have more capacity. They're offline. So we have to forecast that. But what I'm telling you, there's kind of a FUD factor in there. We don't believe we can be precise in making those predictions. So we try to just put in a little bit of extra to make sure there's adequate supplies. Yes.
Do you test your projections if you went back 20 years and said, well, 20 years ago we said X? How does that track the projection we have?
There's always one guy. There's always one guy in the audience who says, you sound pretty good, but have you ever really been tested? in terms of how good your forecasts are. But actually, I'm delighted that you asked that question. Because guess what? My boss, Rex Tillerson, asks me that question every year when I present the energy outlook, because we have this kind of internal discipline to make sure we're not deluding ourselves as we do this. And I'm going to answer in two ways, okay? Because remember, the outlook has a supply side and a demand side. And we have been really, really good on the demand side. As we project the demand for, the future demand for oil and gas and all energy, we've actually done a great job. In fact, this whole energy outlook, I should tell you, is online. I have one book with me, I guess, but it's all available online. And this year, we actually published in the last section a retrospective looking back 15 years. How did we do? So you can go online and check us to see how we did. But we did amazingly well on the demand side. Now, I'll tell you, it's actually easier than you think because the world of energy is so large and the volumes are so big, it's hard to kind of change it dramatically. But we do really well. The embarrassing second part of my answer is the area we've not done so well is on the supply side. Now think about that. This is our core business. This is the part we should be good at. So, and I'm just being honest with you, like the whole shale oil and gas thing, 15 years ago, we did not see this coming. We all knew that the oil and gas was there. We just didn't realize it could be produced economically. So it's kind of an interesting picture that we're very accurate on the demand side, not so good on the supply side, but always erring in the side of caution. You know, I'm an engineer by training. I think as a corporation, we're kind of all have an engineering mentality, so we don't want to put the barrels down unless we're sure they're there. But because of technology advances, the outlook has always been more positive. So in some ways, we've missed some pretty big things. Have I worn you all out? How are we doing for time? I have time for a couple more questions. Yes, Charles.
Maybe this is a little off track, but how do you see China in terms of, given its needs? It appears that they're becoming more aggressive. It'll be good for Houston that they're coming in buying up suppliers, doing stuff to the demand 10 years ago. How do you see that?
Yeah, and the whole question of how we look at China and other what we call national oil companies who are more aggressive in the energy space and actually even buying assets in North America and other places. You know, I always say we like free markets, right? So we have to embrace everyone who comes to the picture. I think everybody brings talent, they bring money, and I think, you know, it's always good to have competition in any marketplace. So part of it is, as a business reality, we have to accept it is what it is. So we want to make investments in China, right? So we certainly need to let them have investments in North America. So as a business, you know, we always support open and free trade and investment. And so it's been a fairly significant factor at times in recent years because as some of the national oil companies have been quite aggressive in that space, they can be tough competitors. But again, the way I look at that is it's good for consumers in the long run. Yes, in the back?
Yeah, on renewable energy,
yes.
Solar and wind, do you see any potential breakthrough as far as technology goes that could disrupt the energy mix?
Yeah, great question about potential disruptors, and particularly for solar and wind, which are the two biggest emerging renewable technologies. And we watch that space very, very carefully. In fact, I have a whole team of people, we have a whole group looking at future emerging technologies because we want to be watching what are the kind of weak signals for things that may become breakthroughs and to take them separately. Actually, wind is becoming a kind of mature technology right now because there's only so much you could do with wind turbines, and so, you know, the cost curve is kind of flattening out for them, although we do show further improvement. Like in wind, they're talking more about offshore wind as maybe an emerging area. But I think the more interesting space has been solar energy, because if you look at the cost for solar, they've really come down quite dramatically over the past 10 years. So that's probably has greater potential for the long term. The fact is, though, solar is still very expensive by any standards today. So most of the growth you see in solar is driven almost purely by subsidies. Like the Germans, of all people, have decided to go big on solar. And it's been very expensive for the Germans. And of course, solar and wind both have the obvious challenge of intermittency. The sun's not always shining, the wind's not always blowing. So you have to kind of back them up with some other form of power. In fact, it's actually good for our business because all the renewables need natural gas to back them up. So that if you don't have power there, you can fire up the natural gas plant. But we watch that space very carefully. I would say the really most interesting emerging technology of all is batteries. If you think about it, if there was a breakthrough in battery technology, it can impact many things. First of all, electric cars could be more competitive, right? And it helps with renewables and intermittency. So you could have the wind. The wind blows very hard at nighttime when you don't need the power. But if you could run the wind turbines at night, store it in a battery, and then use the battery during the day, that could be a breakthrough. So we watch that space very carefully. And in fact, we have a lot of our own scientists working in some of these spaces to help us better understand. And lastly, the other really interesting space, I think, is nuclear power. I mean, nuclear power on paper, looks pretty attractive. But again, it has this kind of social overlay. I always say if they let engineers run the world, we would have more nuclear power. But I've been told they won't let us run the world. And I guess there's good reasons for that. But so there's a lot of interesting technology spaces, and who knows what other things might be invented between now and the year 2040. In the back here.
Have you looked at the effect of possibility of cap and trade legislation on the effect of the demand?
Absolutely. The question is, do we look at the impact of cap and trade, which is a CO2 emissions control regulation in Europe, and how that impacts the outlook? We look at the impact of environmental regulations in every single country because it's so important. Europe has cap and trade, but everywhere in the world there's some forms of environmental regulation. For example, today in the U.S., if you want to build an electric power plant with coal, you have to put carbon capture technology on there. So that's equivalent to $100 per ton coal or carbon tax on those plants. So I mean, every country has some form of kind of cost of carbon. So we look at every single country and try to estimate where we think the environmental regulations are going. And believe me, that is one of the hardest parts of our outlook. We use this thing called a proxy cost of carbon. So we assume, for instance, in the U.S., by the year 2040, regulations will impose the equivalent of $80 per ton of carbon across the economy. And that we work that into our outlook. And that's an area of constant kind of dialogue with regulators. I should say ExxonMobil believes the risks of climate change are real, for example, so that society should do reasonable and prudent things to try to mitigate these risks. And so to us, while the science is there and we understand the science, we even have some of our scientists involved in the IPCC climate report writing, the question is, as economists and engineers, what are we going to do with this information? And what steps do we take that are what I call the middle ground? How do we find a middle way to kind of address these risks, but in a way that's affordable for the world?
One last question.
Yes, last question.
Going forward in the oil markets, do you see OPEC continuing as a swing producer on American shale or something else? What will be?
Yeah, great question. The question is, what is the marginal source of production for the future? And alluding to the fact that OPEC was seen as the marginal supplier in the past. And I would say the world has changed over the past year. I think we're in a new era now where the marginal supply is going to be driven more by economics. So it's really driven more by what's the next lowest cost of supply from a free and open market standpoint. So it's kind of hard to you could say right now tight oil seems to be on the margin, but I think that's going to remain a very dynamic space. And I cannot speak or think for the OPEC members in terms of what exactly they're going to do and how they're going to play this. We're, again, into a new era of abundance. And I know there's a lot of oil people here, so it feels pretty bad. But for anyone who's a consumer, you have to feel pretty good, because that's the other side of the coin. So thank you very much for your time. It's a delight to be with you.